Ethan, how are your holidays? Okay, let's start. Ethan, what are the two types of polymers?
Polymer.
Yeah.
Polyester.
Okay, and polyesters are a bit more specific, something a bit more general. What is polyester? What kind of polymer is polyester? Polyester is a what polymer? Right now, what are the two types of polymers? Two general names. You've done that for your school, right? Have you? Oh, not yet. Okay, come guys. These are the two types. One is addition, the other is condensation. Now, of course, there's a reason why they are called these two names. Basically, they go through addition, polymerization for the first type, and then the second type goes through condensation polymerization. And to refresh your memory, what is the starter material or starting material called? That molecule is called a, again, take note of this name, monomer. So your monomer polymerizes to become a polymer. And just a reminder, it's possible to have two monomers sometimes depending on the situation. So it may not be just one, but it can have two different molecules. Now, Ethan, what are the conditions for polymerization?
Suitable catalyst.
Okay, good. That's all you need to write, because in real life, there are many, many different conditions depending on the polymerization process, depending on the polymer. So for O levels, that's all you need to write. Okay, but let's go back to his earlier answer. Just now he mentioned polyester. Now, polyester is a condensation polymer. The other type in your syllabus for condensation polymer is polyamide. But I also want you to be clear, polyester has actually many, many types as well, with different names. Likewise, for polyamide, many, many types. With all sorts of different structures and formulas. But there's one that you have to know. At this thing, I think I didn't mention this last time. This, you need to know this name. One of the well-known polyamide is called nylon. Just add this in. It comes up once in a while. This is a polyamide nylon. Take note of this name. The other name that you should know under polyester is called terylene. It comes up once in a while. Terylene. And the most popular usage for terylene will be in bath towels. Well, nylon has a lot of applications. As I said, I think I said this before. A lot of your bags are made of nylon. Clothing, ropes, lots. Okay, let's go back to addition polymerization. Okay, there are few popular examples that you need to know. The most popular one is, of course, polyethylene. I believe I mentioned this before, polypropylene. And I believe I give you a few others, but I don't think I want to write down all the names here. And of course, others. I believe I give you 3 more at least. But as I said, the most popular are still this two, polyethylene and polypropylene. I mean, based on your syllabus. Okay, just a note, just to refresh your memory. Why do they call it addition polymerization? Oh, okay. What's the meaning of addition? Addition?
Add two things.
Okay. So yes, he's right. Add two things together. Basically, your reactants form one product only. The important thing is there is no side product. You only have a single product. Well, condensation is sort of like a reverse. Okay, I want to reverse the opposite. They use the word condensation because a side product condenses up. Okay, just take note, condensation involves a side product coming out. And of course, the most common side product is water. All right, any questions, anyone? Let's explore further. I believe we stop at condensation polymerization the last round. Let's explore a bit further. Okay, so polyester. Maybe I start with this. How to identify the. How do you know something is a polyester? You look for this. What we call ester linkages. Yeah, I repeat, how to identify polyester, look for ester linkages. Not surprisingly, for polyamide, you look for what we call amide linkages. Recognize the structure of the linkage. I'm going to draw this up. You will find this within the molecular structure. Look for this group. This is your ester linkage. But of course, you should remember what functional group is this. What functional group is this? It's basically your ester functional group. Okay, but if you find many of this together in the same molecule, then it's called an ester linkage. Okay, otherwise, if it's alone, you only find one within the molecule, then it's basically an ester functional group. Recognize the amide linkage too? It looks like this. Okay, so recognize the amide linkage. If you find many of this within the same molecule, then that is a polyamide. Okay, come, let's start. How to make a polyester. Okay, two possibilities. Now remember, I said you need a monomer. So if I want to form a polyester, what is my monomer? Well, I think intuitively it seems, oh, my answer is ester. All right, it seems that way. It seems that way, but the answer is not. What is my monomer then? Okay, it looks something like this. I draw the structure for you. I have this thingy. This can come up in your test and exam. They give you a rectangle. It represents something, some a particular structure. But this is the important part. This is the monomer. Is it an ester? No, of course not. But you have to recognize this group. Ethan, what group is this? Alcohol? No. COOH. COOH is a yes, is a carboxylic acid group. Nothing wrong with saying carboxylic acid group, but to be more exact, it's called your carboxyl group. But at the other end, you have this. Arena, what group is this? Yes, alcohol group. But of course, if I want to be technical, then I'll call it a hydroxyl group. Okay, so you have a molecule like this. One carboxyl group. At the other end, you have a hydroxyl group. What happens next? So if I get this molecule, okay, so if I put two of them side by side, this is going to happen. Okay, for the matter, three of them side by side. Okay, try to work carefully. I put three side by side. This H will come out. This OH will come out. Okay, so look carefully at the carboxy group. OH comes out. At the hydroxy group, H comes out. Of course, you should notice this is water. Water. What happens to the rest? This joins here. This joins there. And you continue joining for at least a few thousands, at least a few thousand. So I repeat, I said earlier, this is condensation polymerization, so water condenses out. What else do you notice? Hopefully you see this. You see this. Well, of course, that's one too. Okay, so you see your ester linkage. Okay, next. How do I draw a repeating unit? Sometimes your question will ask you, draw the repeating unit. Okay, so just look what is repeated. So this is my repeating unit. This is my repeating unit. So contrast this is monomer. Oh, I have removed the monomer, but I'll draw this again. Compare this repeating unit to the monomer. Monomer looks like this. Okay, this is the monomer. This is the repeating unit. Looks similar, but they are not the same. Notice my monomer has the OH there, it has the H there, but over here, H has disappeared, OH has disappeared. Okay, next. How to draw the polymers? You're not going to draw 1,000 of them. There's no way you want to do that. So therefore, polymer is based on the repeating unit. I take this repeating unit. Add in your square brackets. Try to cut across the bond. Try to. Some teachers are quite particular about that. And at the end there. Okay, so this is how you draw your polymer. So let me emphasize, look at your question. Do they want you to draw the monomer or one repeating unit, or do they want you to draw the polymer? Okay, the patterns are all slightly different. Yep, so there's a polyester. But I did say there are two ways to make a polyester, right? So this is your polyester one. There's another way to do it. You just let her copy down first. Now let's go to the second way. How to make a polyester. So I'll call this polyester 2. Okay, come try to watch carefully. This one is different. Huh? So for polyester 2, I need 2 monomer. Obviously, they're different. That's why I use the term 2 monomers. So the first one looks like this. Hopefully you recognize by now. There are 2 carboxylic acid groups. Okay, there's a name for that. Occasionally, you see it in your questions. This is called a dicarboxylic acid. Di means 2. You need a second monomer. It looks like this. So let me have a different group here. Okay, you can see this. So if your question gives you all these shaded rectangles and so on, you replicate it. You make sure you draw your shaded rectangles too. Okay, the second monomer looks like this. Well, hopefully you remember by now, you have 2 hydroxy groups or 2 alcohol groups. So this guy is called a dipole. Even though there's an exact name, but it's outside your syllabus. Okay, so what happened next? You put this molecule here, you put that molecule there, next to, oh, hold on now. Okay, next to each other. But you need more than two, of course. You need a lot more, thousands of them at least, even millions. I continue putting them alternately. Guess what? The same thing happens. Carboxyl group, OH comes up. Hydroxyl group, H comes up. Again, hopefully nothing new to you. Water has condensed out. You see all the water molecules there? Then, what happens to the fragments? Okay, they join. Since you're done, try drawing the repeating unit, try drawing the polymer. How do they look like? If you are asked to draw one repeating unit. Okay, Arena, you too. Try drawing one repeating unit and the structure of the polymer. If you have finished, let me take a look. Oh, itu kan? Okay, good. Okay. Now you can just take note of the bonds. Make sure it stretches out of the bracket. Okay. No problem. Oh, where's your pen? Oh, yeah. Also, in your exam, if they shade it, make sure you shade it as well. Huh?
You need to shade.
Yeah. If your question is shaded, then you have to shade too. Okay, this side try to don't forget the bond stretching out as well. Okay, let me just do. What if they ask you to write the equation for this polymerization? How to write it? So, okay, in this case, I take a monomers. It doesn't come out all the time. Once in a while, they'll ask you to write the equation. Now, in this case, you can use the structures. So I put N of this plus N of that. And that is when you get your polymer. You can use structures to represent your equation. Yeah, hopefully you recognize. So I have my monomer one here, monomer two there, and my polymer on the right. So that is your equation for your polymerization reaction. What is missing? What is missing from the equation? What else should I add inside? Yes, water. How many moles of water? 2. Yeah. Okay, should be 2 in H2. And you see Y2N, just 2 guys alone can contribute 2 water molecules. I mean, this doesn't come out all the time at once, they'll ask you to write the equation. Oh, but of course, there are also times they give you the exact number. That means it's not N anymore. They'll tell you 1,000. 1,000 of the molecules, monomer 1 and monomer 2. So make sure you put 1,000 then. Do not put N anymore. So of course, my water should be 2,000. Occasionally, they'll give you an exact number too. Okay, so just be very adaptable about that. So yeah, that completes your polyester. 2 types of polyester. Okay, next one, polyimide. Quite similar. Let me use the same structure. Right, so how to make a polyimide? Similarly, there are two types. Polyimide 1. What monomer do you need? Okay, look carefully. In this case, you need something like this. Yep, look familiar. But this side is different. There's something new for you here. Well, you still have your carboxyl group. But on the other side, there's something new. It's not exactly in your syllabus, except in this last part on polymers. Okay, what is this? This is called an amino group. Now, of course, if you do bio, you should recognize the name amino. And by the way, no need to know, except unless you're doing bio, this whole thingy is called an amino acid. So I don't think this will come up for chemistry. Okay, but let's continue. Right, so how? Exactly the same thing. I have lots of these guys, lots, thousands of them. Okay, so here I'll just show you three. Now, it looks quite similar to the polyester. This one, let me get rid of this first. This thing comes out. Okay, stable. From the carboxy group, OH comes out. But from this side, what comes out? The H comes out. Okay, continue. OH comes out from the carboxy group. From the amino group, H comes out. Yeah, I hope you see the same pattern occurring. Water condenses now. Join the fragments together. Same thing, I want each of you to draw out repeating unit and the polymer. How do they look like? Ethan, done already? Come.
So the length is 7 cm. So life factor if you're do you see also kind of
Good.
All the money was like over it's like a green tower and yeah.
Okay. Now, one last thing. Hopefully you recognize something. This group here, this group there. So those are your amide linkages. So yeah, of course, that's why it's called polymer. For the next one, probably you know how to do it already, but I'll just walk through with you. So there's another way to make a polyimide. So I'll call this polyimide 2. Now, of course, not surprisingly, in this case, I need 2 monomers. First one looks like this. Again, looks very familiar. Oh, Dylan, what's the name again? Yeah, of course, it has 2 carboxyl groups, but together the molecule is called a
Carboxylic.
all right. So occasionally you see this name in your test and exam. It's dicarboxylic acid. Well, so I guess you won't be surprised to see the second monomer. It looks like this.
Oh, yeah. My name is Speed. So that yeah, she said she didn't say Speed.
Yeah, of course, you should be able to see the 2 amino groups. Okay. There are 2 amino groups. So we call this molecule diamine. You will occasionally see this word. All right, come on, guys. Now I'll give you a bit more leeway. Draw out the repeating unit you expect to see and the polymer structure. You allow them to polymerize. How does your repeating unit look like? How does your polymer look like?
Bring it to you, so it's more nice. I think I was yeah, I was so maybe I was still going to just those one of it's now because okay. Okay, let me just number that in your side. I just need to show you. I need to go to step because you know, if you have case to do it, there's no way. Where you don't get you love the pressure mind. Oh wait, I get it. I can't again, but I can't again. Wait, so is this MX plus? Oh, yeah, I get it. Right, okay, because they use the X, just don't think it's a great, and call it a day, that's all. Call it a day. It's a day. Oh, it's a day. We think I think we
Okay, good.
Oh, you get it now.
Ethan, Dylan, done?
Yeah.
Okay, I think we'll have no problem now. Now, just a couple of things before I wrap up this chapter. I wrote this earlier, polyester, polyamide. I said that there are many types. Polyester is not just one or two. There are many, many different polyesters and many, many different polyamides. But why? Didn't I just tell you there are only two, polyester 1 and polyester 2? How come there are many types in the real world? The thing is here. What is inside here? That makes a difference. There are many possibilities. Okay? Later I'll give you the worksheet and then you see for yourself. So just bear in mind, I can have many different things within this box. Same thing here. If I have two monomers, I can have many different things here, combine many different things there. That is why you have many, many polyesters and polymers. Okay, any questions, anyone? Okay, just one more thing. In the previous lesson, did I mention what are the uses of all this polyethylene, polypropylene? I think I did, right? Uses. I give you 5, I remember: polystyrene, polyvinyl chloride, polyvinyl acetate. You write that down? Did I give you 5 types? Yes, right, Peter? Did I tell you the users? Okay. But anyway, I'll just write a few here. Polyethylene is your plastic bag, as in not your backpack, but your Sheng Siong bag, NTUC bag. Polypropylene, typically not for bags, but more for like something hard, like your chair or even tables. But can you see a contrast between these two users versus these two users? Is there, can you see something in general between condensation polymer versus addition polymer? It don't talk about structure. I'm talking about the users. Okay, here's the thing. This tends to be a single piece of plastic. Like plastic bag, yeah, it's a single piece. Of course, you can stretch it, but it's still a single piece. A chair, the one that you're sitting on right now, is a single piece too. But if you look at condensation polymers, more often than not, they are in the form of fibers or threads, if you want to call it that. And they have been spun into a product. Oh, okay, let me be more specific. They are spun into fabrics. Okay, so take note. In terms of users, that is quite a fundamental difference. It doesn't come up often, but something may be useful to you. Questions, anyone? No? All fine? Okay, let me give you the option.
With eyes. I can help. We can help. Right. And that means school feel like this, you know, and I don't know. I see wrong. Oh, so you guys take the time. It's not what I feel like you have to pull out. Then those some people are that this is funny. Well, I don't feel. I don't think something I'll do. You're not tea. I don't think you really are against it. It's fine. The Bentley and I think. So you don't have to touch your beach pants on the I don't know again. But the thing is, we failed at that last year. I'm like, what's she? No one loved the young girl. If I don't say, it's a white cable. You meant my calculator. She meant my paper. You from your basketball? She meant my calculator. I don't want to do. Oh, I did it. Wait, what's it? I said she meant my calculator. I don't know about you. Yeah. I don't get it. I don't get it. It doesn't make sense. Sometimes how open you are. Sometimes how open you are unaware. You know what restaurant no, what shop is how aware you are unaware. Oh, you don't me as well. I don't see the words. Oh, I'm aware you are. I just see the cat. I just. Yeah, you know that. Oh, wait, I understand. No. Wait, I know people there. No one did. I feel extension. Yes, we are having a safety also. Gibbleton. Yeah, Gibbletons. Gibbletons. Yeah, there's the. Maybe you're somewhere. Gibbletons. I have issues. Okay. So really give you the okay, y equals to by 1x number. So this is the number. So they give you this equation. And then you want to find x where y is 2. So it's just it's something about it. It's basically y and 2 into 3. And you want to find x equal 1. It's very simple. You just do normally and just not normally for x. What you have to do for work too? Yeah, it could be it. So how do you find x? Divide by what? The position with this negative figure, right? Like this one, what is 3 over 2 divided by negative 1? What? I'm not sure. What I love it. Big money. Oh, no. The tree is a this is wrong. This I minus half on both sides. So 2 minus half is 2. 2 minus half. Just minus. I think this side you are going to do. From now on, we find x divide by divide by this number. You just send your calculator lah. You just do your part. Then it's good. And then it is the same control sound and oh, but it's a beautiful song. So I can never listen to that. Wait, that no. It's so true. Relax on it. You're right. Divide by negative 2. And then divide by negative 1. Okay. Those ones. Little ones, yeah, music. We started music one. There's a music. Oh, that's really nice. I have to see how after your other question, it's now time to turn 8. It's 6%. Literally. And I'll talk about the last one. But the rest of something different. And then look how he's not seeing. Wow, I think what? How could you say? I'm in love with you. Yeah. Rather than just continue. No, he's skipping numbers. So why is skipping numbers? That's 7 hours. And I want you to do it. How does that refresh my people?
Okay, guys, let's go through the first parts. Make sure that you're on the right track. Okay, Ariana, first one. Okay, fine. Wait, many? Yeah, okay, fine. Large, big, small. Uh, I, I, I can't remember whether I mentioned this. The word macro itself simply means big. Macro. Okay, next one, Ethan. Link. What are linked together? No, this blank here is what are linked together by many small repeat units called. Okay, the word here is polymers. So what are the repeat units called? Yeah, monomers. Okay. I mean, technically they are not the same, but it's as close an answer as can be found. All right, Dylan, what are the two types of polymerization? Addition, good, and condensation. Next one, Arena. Under addition, without producing any molecules or atoms. Okay. Not exactly, because they must produce something as a product, but they do not lose anything. Now, on the other side, condensation. Yep, Ethan. Monomers join together with the what? With the what of small molecules. Sure, I can put the word loss or remover. Now, Ethan, nylon is. Yep. And beryllium is. Yes. Try not to get it wrong. Come, Dylan, next blank.
On biodegradation.
Okay. Once in a while, it can come out. Just take note, in general, plastics are non-biodegradable, even though they are biodegradable ones nowadays, but most of them are still not biodegradable. And as a result, they cause pollution problems, and they may produce, this one I'll tell you, poisonous or toxic gases even. Okay, next one. Arena. Two, yeah. Ethan. Yes, take note. You must have C double bond C. Next one, Dylan. Why?
Because there's also water as a product.
Yes, there is a side product. Usually water, but can be other molecules too. Okay, there's a side product. Arena. Okay, this one I didn't really mention. Nowadays, can you just add in into your list? Teflon is an addition polymer. Structure-wise, it looks like this. There's Teflon, and where can you find it? It's used as a plastic coating for frying pans. Look at for that dark black or gray coating on your frying pan. That is usually Teflon, even though there's other substances nowadays. Ethan. Yep, true. Last one, Dylan. Yep, true. But just take note, sometimes they ask about pollution issues of plastics. Okay, MCQs. Number one, Arena. B for dog. B for boy. Okay, yeah, you must have the C double bond C. Hopefully, all you got it right. This one must be there. This one must be there. Next, number two, Ethan. C, okay. And if anyone gets it wrong or you're not sure, please voice out. Number three, Dylan. See, that's the major issue. They are not biodegradable. Number four, Arena. B for boy. Okay. All right, show your answers. Can I? Right, number five, Ethan. A. 6, Dylan. B. Okay, come guys. You definitely recognize this. So this one means it can perform addition. But hopefully you also recognize these two groups. So it is a dicarboxylic acid, and therefore it's possible with another monomer to undergo condensation. So this particular molecule has a possibility of forming two different types of polymers. It's possible. 7, Arena. Okay. Okay. No, I hope no issues. Okay, if there's any question to voice out, let's go to this one. Draw the structure of the polymer, showing 3 repeat units, guys. I want you to be very specific. They ask for 3. Make sure you draw 3. Okay, let me quickly check your drawings. Oh, you didn't draw? Didn't you draw? I think so. Here. 1, 2, 3. Yeah. Good. 1, 2, 3. Okay, good. Oh, but Arena, you're able to draw, right? Oh, you don't know. Okay, come. This one is going to become this. This is the monomer. So as the polymer, it's going to be like this. Double bond is gone. Instead, you stretch one more bond to the left, one to the right, square brackets it. This is the polymer. But they ask for 3 repeat units. So how? Then just draw 3. Without the square brackets. So yeah, just continue the pattern. Yeah, that's all. You do not need square brackets, guys. Don't put square brackets, don't put n there. They ask for 3 repeat units. Okay, come Ethan, how many repeat units are shown? Yep, 3. Draw the structure, the monomer, and state its molecular formula. So I need to see both your structure and your formula. Yeah, good. Good. You remember the double bond. C2H. Okay. It wasn't too clear, but fine. Haven't done it.
Where is it?
Oh. What are you writing? Okay, good. Okay. Oh, done? Formula? Oh, you don't know what's the formula? Okay. C2H3Cl. Always starts with C, followed by H, then followed by O, but there's no O, and then followed by halogens. Okay, so the simplest way to write it is C2H3Cl. Job done. Let's finish with this one. Okay, Arena, what's polyimide?
So polymer that's light in the
Okay, Well, there are no marks here, so at least you need to have the word polymer in your answer, right, with amide linkages. They didn't ask for anything else that would be good enough. So you don't have to really mention the monomers and so on. All right, structure on nylon, 2 repeat units. Where? Sorry. Oh. Yeah. Okay, and then there are 2 types of polyamides. Either one is fine. Make sure you have 2 repeat units. No, this one. How many units do you draw? Count. Done? Done? 2B. Yeah. Okay, this is fine as well. Either type of polyamide is fine. Can?
Yeah, I'm doing 3 days.
Yes, correct. So just be a bit careful. Yeah. Okay, then this is 2. Okay, look at the question carefully. Right, guys, it's almost time. Any questions for today? No? All right, if not, then bring this along next week. We'll complete it next week. Early, Fikra. Your school has finished this chapter, right?
Yeah.
Oh, no. Oh.